-5. Calculate the pH. So we've got the amount of H+, there's the pH there. But remember, it's after the pH change, so we've got to subtract the two difference. So the pH change is from 4.73 to 4.68, so that's the change. That is tough, but if you get your head around this bit in the red box, then you're flying. Okay, so where do we use these buffers? They seem awfully complicated, but incredibly useful. So buffers have many uses in household products, naturally occurring in living things as well. Blood is a classic example of buffer. If you didn't have a buffer system in your blood, you would not be alive. It's as simple as that. And it works day in, day out. And it's constantly rebalancing the ions in your blood to make sure it's at the perfect pH. If it's not the right pH, it's simply enzymes wouldn't be able to function, cells wouldn't be able to adapt, so it is vitally important. So it is absolutely worth knowing about it. So it must be as close to 7.4. That's the pH of blood. We need that to be the same, like I say, to allow bodily functions. But carbon dioxide plays a massive role here within blood plasma. So we have what we call a carbonic acid and hydrogen carbonate, which is HCO3 system. So we have your carbonic acid, which is here. This dissociates into H plus and HCO3 minus, so that's your acid bit. And then we have this system going on as well, where you have H2CO3 and water and carbon dioxide. So you've got your carbon dioxide that already exists in your blood. And so this is the buffer system that occurs in your blood with carbon dioxide. Now, the amount of carbonic acid in the blood is controlled by respiration in your cells. So we breathe out carbon dioxide and the level of carbonic acid reduces as equilibrium shifts to the right to replace them. So when we breathe out, we're breathing out some of that carbon dioxide because we've produced it from our cells, respiring. Okay, that carbon dioxide reduces, and so therefore the equilibrium shifts to the right to replace them. So some of this acid moves across to replace the carbon dioxide that's been lost. So we do need carbon dioxide in our body. We don't have to get rid of all of it. Hydrogen carbonate, which is HCO3 minus, so this carbonate ion here is controlled via your kidneys, and if there's too much of this in your blood, that's just removed through your urine. So it's a fine balance between them, and your body's got numerous ways to either get rid of this or to retain it. And that's it. So that was a bit of a marathon. A tough topic. It's not an easy topic. If you did find it difficult, then there's a reason for it. It's not an easy one. But please subscribe to my channel. There's loads more videos on this that go through all these some of these complicated areas, and hopefully it'll go a little bit of a way to try and help to explain it. This is available to purchase as well, so you can have your own copy. If you click on the link in the description box, and that will get you there. But please subscribe. These are all for free and always will be. All I ask is that you just hit the subscribe button, and that just keeps you in the loop regarding these videos. But that's it. Okay, bye bye.